Welcome to Study Loop.
Going to get going here. I've got a really rough diagram, but you should reference the text for all the numbers. I'm just going to be using the numbers in the problem because there's a ton of numbers here and there's no way I can draw it. Okay, so we're going to consider the link AB. I do have my A's and B's up here. This is A, I think. No, this is A. This is E, which I have. Okay, so we're going to consider the link. Let's change colors. And the VA will be equal to VB plus VA over B. Let's call this equation 1. And for equation, let's consider link ED, and the velocity at point E will equal VD plus VE divided by D. Let's call this 2. And then we're going to get the velocities. So VA will get this times RA over B, and this will equal angular velocity of OAK times negative 0.1 I plus 0.2 J. And that will give me negative 0.1 plus 0.2, or minus 0.2. I did that wrong. J, and this is I. There we go. And for VB, this will be equal to negative pi K times 0.05 J, and that will equal 0.05 pi I m per s. And for BAB, we're going to get WAB angular, and this will equal negative 0.3 Okay, and then we're going to use equation 1. We're going to substitute our values. Which is way back on the first page of this. Minus. Okay, and then consider the J coefficients. This will equal and consider the I coefficients. And this will get me and then solving for this, we'll get okay. And then for WOA, we'll get 3 times 0.2856. That'll equal 0.8568. Okay, and then we're going to use equation 2, and we're going to get our VE and this will be VEI equals 0.8568K times 0.6J plus this EDK times the square root of 0.12I minus 0.20J. Okay, so for the J coefficients, we get this. And then for the acceleration, at point A, let's call this equation 3. And then another equation is this one. And our acceleration is equal to negative. That'll be times. And okay, let's call this 4. Okay, and considering our angular velocity at crank B, let's find the acceleration at B. And this will equal 0 plus 0 times R BC minus pi squared 0.05J. And this will equal negative 0.49 0.35 j meters per second squared. Then consider the angular acceleration components along AB and this will equal negative 0.2856 squared times negative 0.3I plus 0.05j, and that will equal 0.08157, 0.3I minus 0.05j, and that will equal 0.024471I minus 0.00408j meters per second squared. And then for our tangential acceleration, this will be equal to, that'll be equal to and that will be equal to negative 0.05 okay. Then we're going to use equation 3. We're going to substitute our coefficients in. So let me do this. And for the I coefficients and the j coefficients, we get and this will be this is 5, and for the j coefficients, okay, and then we'll get 0.3, and here we have 6. So we'll get angular accelerations in 5 and 6. We get negative 1.1867. That is for AB, and for OA, negative 0.0519. Then we're going to get an acceleration for E. Okay, this will equal this times ROD. This will equal 0.8568K times 0.8568K times 0.6J, and that will equal negative 0.4405J meters per second squared. Then ADT we're going to consider that the angular acceleration of link OD has to be equal to the angular acceleration of link OA. So we're going to consider that angular of OA is equal to angular of OD. That equals negative 0.0519. So we're going to get ADT is equal to, times ROD. This will be equal to 0.0519 K times 0.6J, and that will equal 0.03114 I meters per second squared. Almost done. Now the acceleration components for, let's go to the next page. A, E over D, N will be equal to 0 times, I already did this equation, times the square root of 0.12I minus 0.20J. So this will equal 0, and AEDT will be equal to and this will be equal to 0. No, let's do this first. And this will be equal to okay. Then we're going to use this. And we're going to get this. And then for our J coefficients, we're going to hit 0, negative 0.4. And this will, my alpha ED, 0.4405 divided by the square root of 0.12 equal 1.2716 per second squared. And for my I coefficients, I get AE equals and that'll equal 0.285 meters per second squared, right. So we're going to get 0.285 meters per second squared to the right.